Question 2 tests our knowledge of calculus. Here we are asked to find the values of b and c of the quadratic function f. To start, we'll find the first derivative of f. We are told that f has a local minimum at the point 3, minus 1. This reveals two important pieces of information. Firstly, it tells us that the coordinate is on the quadratic curve, so when we substitute these points into the function, we know we have a true equation. Secondly, the coordinate 3, minus 1, is the local minimum, so when we substitute 3 for x into the first derivative, we also have a true equation. We can estimate that our quadratic function is going to look something like this. Let us rewrite our equations side by side for better clarity. We can solve the first equation, since it only has one variable. b is equal to minus 6, so we can substitute this value for b into the second equation and solve for c. Part B asks us to find the following limit as n approaches infinity. Since our function is expressed as a sum, we can compute the limit of each of the terms in the sum individually. Starting with the first term, we will investigate the result of subbing in larger values of n. We can see that the result gets closer to 1 as we increase n. Analyzing the second term, we can also see that the result is 1 as n approaches infinity. For the last term, the result of increasingly larger values of n is 0. This makes sense as the denominator is rapidly getting bigger, but the numerator will always be 1. When we add all of our individual limits together, we get 2. Part C wants us to plot some transformations on the function g. In Part I, we need to plot g of x minus 2. Every single point on g needs to be moved down by 2. We can see why that is by looking at a specific example. When x equals to minus 2, y equals to 4, but when we subtract 2, y equals to 2. This will happen for all the points on g. We will extend our domain as large as possible, just as the question asks. The second part of this question asks us to plot g of x plus 3. This time, the function will move to the left by 3 units. You can verify this by looking at some specific points, just like we did for the previous part.